Hello, welcome back everyone. So let me quickly recall in the last class what are the things we had covered. So we saw that practically useful crypto system. So encryption and decryption should be easily computable, and an opponent after seeing the ciphertext should not able to determine the key or plain text, and the process of attempt to recover the key or message, that is called cryptanalysis. And then Bacon had proposed the following property for a good crypto system. First thing, as I told you, encryption should be easy, decryption should be easy, should be easily computable. Third is ciphertext should not be much larger than the plain text, and then by looking at the ciphertext you should not able to get back the message. And avalanche effect should hold in crypto system. Avalanche effect is an effect by which small changes in the plain text or in the key lead to big change in ciphertext. Now crypto systems should not be uh, closed under composition. That means suppose I am having two keys, there should exist a key k such that ek of w is equal to ek1 of ek2 of w. That means your message is encrypted with k2 and that encrypted is encrypted with k1. This should not be decrypted by a single key k. Okay, set of keys should be very large. And then Clad Shannon has given this confusion and diffusion property for a good crypto system should satisfy. So what is confusion? Key is not related in a simple or direct way to the ciphertext. Each character of the ciphertext should depend on several part of keys. So confusion is high if each bit of key has an influence on many bit of ciphertext. So in short, confusion gives the relationship between keys and ciphertext. Whereas in the case of diffusion, when change on the character of a plain text yield change in all the character of the ciphertext and vice versa, then it is called diffusion. The idea is to hide the relationship between ciphertext and plain text. Diffusion is high if each bit of plain text has an influence on many bit of ciphertext. Okay, now let us start with cryptanalysis. What do you mean by cryptanalysis? It deals with the study, observation, and analysis of crypto system in order to attack on it. Attack on it. Okay. So there are standard assumptions for cryptanalysis which relate its practicality in real world. Dutch cryptographer Kirchhoff Kerckhoff has formalized standard guidance. So what is Kerckhoff principle? Let us see. Sorry, this should be key. Kerckhoff. Kerckhoff principle in cryptography. What does it say? It says that a crypto system should be secure even if everything everything about the system except the key is publicly known. except the key is publicly known. So it says that a crypto system should be secure even if everything about the system except the key is publicly known. So thus we test the security of crypto system under the assumption that security of the crypto system should depend on the secret key, not on the algorithm. Hmm. Security of crypto system should depend on key or keys, not on algorithm. Okay. Now let us see types of attacks that can be, or types of attackers first. See, when a sender Alice sends an encrypted message to Bob over a channel, then an attacker, we call it as Eve. So I'm having Alice, I'm having Bob, the attacker Eve, we call it as eavesdropper, has the following privilege to access, or Eve has the following privilege. You want to send a message to Bob or access in the communication. Okay. But the privilege he has, first thing is he can read the messages which are when correct, that is the ciphertext. Read the message which is going through the channel, and he can try to get the key, and he can try to get the key that was used, and then decrypt all the encrypted message. If he is able to do the thing, the same key, this is called total break. This is called total break. If he found a key and he is able to decrypt all the encrypted message, then that is called total break. Next, what you can do, yeah, you can change the message sent by Alice into another message in such a way that Bob considers the message as if it is actually from sent by the Alice. That means Eve can pretend that it has been sent by him. No, Eve can actually alter. This one is Eve can change the message sent by Alice. Okay, this is called modification attack, or attack on data integrity. This is called modification or attack on data integrity. Yeah. Next, Eve can pretend that he is Alice. Eve can pretend to be Alice and communicate with Bob. With Bob. So this is called mask reading. This is called masquerading or man in the middle. Man in the middle attack. Okay. So therefore an attacker can be passive or active. There are two type of attacker. Therefore an attacker or eavesdropper, Eve, can be passive or active. So what is difference between a passive attacker and active attacker? A passive attacker can only read the message. Can only read the message. So attacks that threaten confidentiality are passive. That means he is able to get to know the message. He is not taking any action, but now your privacy is at danger. Passive attacks. Okay, and what is active attack? An active attacker can even modify the message. Modify the message or can harm the system. Or can harm the system. So here the attacks that threaten the integrity and availability are active attacks. Okay, yeah. So if you see, then the potential adversarial goals are, what are the goals of an adversary? The first thing is total break. You want to find the key. Total break means to determine the secret key. Secret key. Second thing is partial break. Partial break, that means to determine some specific information, to determine some specific information about plain text, or to decrypt a previously unseen ciphertext. With some non-negligible property or probability, with some non-negligible probability. Okay, and third is distinguishability. Distinguishability. What do you mean by this? That may distinguishability of ciphertext. He is able to distinguish between two different ciphertexts. To distinguish between encryption of two given plain text. Encryption of two given plain text, or between an encryption of given plain text and a random string with some probability exceeding 1 by 2. Yeah. So now types of attack. There are different types of attack. So there are 6 type of attack that you might be able to follow. So the difference among these attacks are on the basis of amount of information that Eve can determine during his attempt to recover the secret key or the target plain text. The first one is ciphertext only attack. Ciphertext only attack. Yeah, as the word says, the cryptanalysis get the ciphertext, correct, that is encryption of a message, and try to infer the key or the plain text. He is given a list of ciphertext only. List of ciphertext is given only, and he had to find the plain text or the message. Second is known plain text attack. That is also called KPA. What do you mean by that? The cryptanalyst knows some pair of message, know some pair of message and its encryption. Say message and encryption of the message, that is ciphertext. So he knows some messages, say I is running from 1 to n and the ciphertext of it, and try to infer the key or the the question is try to find the key, try to find key, or try to decrypt a new message, a new ciphertext, try to decrypt a new ciphertext which is not in the list. So this is called known plain text attack. You are given some plain text and the ciphertext corresponding to it, and you are asked to find a decryption of some new messages, say ek of say mn plus 1. Try to decrypt it. Are you able to decrypt? So this is equivalent to the fact that attacker can access the encryption oracle of the message known to him. Can I write? Attacker can access the encryption oracle for messages known to him. Okay. Third is chosen plain text attack. So the cryptanalysis can choose plain text and get the ciphertext. He can choose the plain text out of, say, I'm having M1, M2. This is the plain text which he is having. He can choose any of the plain text and get the ciphertext on it, and again try to get the key or try to get the plain text of a new ciphertext. Okay, this is chosen plain text attack. So this is equivalent to the fact that attacker can access the encryption oracle for the message chosen by him. So in public key crypto system, adversary always has the privilege as in PKC encryption key. Where see in the known plain text attack, the plain text was known. Correct. Where here he have to choose. The attacker have to choose. There is one more that is chosen ciphertext attack. What is chosen ciphertext attack? So the cryptanalyst can access some pairs. That is, he can access some pairs of ciphertext and its decryption of ciphertext, where the ciphertext CIs are chosen by himself. And then again the question is yeah, here he has the access of decryption oracle. He has access of decryption oracle on the ciphertext chosen by him. Okay, but yeah, this is limited. Your I is running from 1 to n. Next is adaptive chosen plain text. Adaptive chosen plain text. What do you mean by that? So the cryptanalysis can choose any plain text message M dynamically. That means here there is no limit. The plain text can be selected on the basis of response of previous selections. So there is no limit. He can choose any plain text and get the ciphertext of it. And then the question is again so to find a decryption of a ciphertext. So this is equivalent to the fact that attacker can access the encryption oracle for the message chosen by him adaptively. There is no limit. In the previous case there was a limit. So let me see something like this. He can choose a message mi and he can get the encryption of mi. Okay, where I is running from 1 to infinity, except the desired one, except the desired one. Next is yeah, this is, there is a shortcut for this. We call it as CPA2. Then adaptive choose an ciphertext. Again, in this case, what happens? The cryptanalysis can choose any ciphertext dynamically and can get the corresponding plaintext. So here he can choose any ciphertext and get the decryption of the CI dynamically. That is, it is not known to the writer also. So again, you can say I is running up to infinity except the desired one. So this is equivalent that he has the access to the decryption oracle of the message chosen by him adaptively. Okay, so if you observe one thing, in the symmetric crypto system the encryption and decryption keys are same, hence the key is secret. So without knowing the secret key, no one can encrypt or decrypt any message. Therefore in symmetric crypto system, attacker either find the ciphertext. uh, in symmetric crypto system, attacker either attempt to find the plain text of the targeted ciphertext or tries to find the ciphertext of a targeted plain text, because the key is the secret here to replace or modify the actual ciphertext. But in the case of PKC, that is public key crypto system, the encryption key is always publicly available. So if the encryption key is always publicly available, that means he can uh, encrypt any message. So this known plain text attack is of no use here, and chosen plain text attack is of no use actually. Hence the attacker can encrypt any message, and therefore there is no sense of CPA or CPA2 in public key encryption. Thus we test the security of encryption in PKC against CCA or CCA2. This is CCA2. This is CCA, and here this is CPA. Yeah. See, and we can use PKC for authentication, digital signature, then message and plain text of signature. Then in that case we have to use CPA, because in the digital signature our message is signed. We'll be coming to that. Next is security norms. Yeah, how to measure or test the security of a crypto system? That is a big question. It is one of the most considerable issue in the cryptography. Following are some various approaches to evaluate the security of crypto system. The first is computational security. What do you mean by computational security? Under this measure, we test the computational effort required to break the crypto system. So a crypto system is computationally secure if the best known algorithm used by the current computer technology is unable to break the crypto system. If the best known algorithm used by current computer technology is unable to break the crypto system. Break the crypto system within a permissible time period. Within a permissible time period. Okay, so it is very difficult to define a permissible period here. Hence, no crypto system is defined to be secure under this definition, because the time period is main part here. So if the security of any crypto system is based on some hard mathematical problem in number theory, such as integer factoring problem or discrete logarithm problem in certain finite cyclic group, then such a crypto system is referred to be computationally secure, as its solution have not been achieved yet with available resources. That means the security of crypto system is based on some hard problem. Then that is your if you are able to break that, if you are able to solve that problem, then your crypto system will be broken. So that is computationally secure. The security of any crypto system. Number theory hard problem, like integer factorization problem, DLP, and so on. Okay, this was computational security. Next is probable security. What is probable security? So in this approach, we associate the security of a crypto system to some hard intractable mathematical problem. Okay, so you see, in the case of computational security, main focus on the was on the computation. Okay, so maybe I can, so that you do not get confused, I can remove this part. Here the focus was on computation, computation only. And in the case of probable security, the security of crypto system, security crypto system is associated or to some hard intractable problem, to some hard or intractable problem. Okay, so we rely on the fact that attack on crypto system will be equivalent to the solution of hard problem. Attack on crypto system is equivalent to solution of hard problem. Which has not been solved yet in permissible time frame. That means if you are able to solve this intractable problem, then you are able to attack the crypto system. Third is unconditional security. A crypto system is defined to be unconditionally secure if it cannot be broken even with infinite computational resources. It cannot be broken even with infinite computational resources. So under this measure, we provide infinite computational power to an attacker. This is the categorically clear that an unconditional secure crypto system must be considered to be the strongest crypto system, because you are able to apply all the computational power and infinite computational power, but still if you are not able to break, then your crypto system is very much secure. Next is semantic security. So in this approach, it is observed that whether given ciphertext leaks any information about plain text or not. Whether given ciphertext leaks any information about plain text or not. Okay. So if the attacker cannot get any information about the plain text from the target ciphertext, then such a system is called symmetrically secure crypto system. So all deterministic crypto system are not symmetrically secure system. For example, see, suppose I am having two ciphertext. See, I'm having a message M and I'm having two ciphertexts C1 and C2. Okay, and suppose I'm having message M1, I'm having message M2. Just by looking at this ciphertext, my question is, just by showing you the ciphertext, the question is which one is the encryption of M1. If you are able to guess that, then it is not symmetrically secure. But if you are not able to guess by looking at the ciphertext which one is the encryption of the message M1, then it is symmetrically secure. So all the deterministic crypto system are not symmetrically secure, because deterministic crypto system, this message M1, if I encrypt, I'll always get the same ciphertext even. So to achieve the symmetric security, the system must be at least randomized. All deterministic crypto systems are not semantic secure, because they will leak some information about the plain text. So to achieve the semantic security, the system must be at least randomized. To achieve the semantic security, the system must be randomized. It should use the random number in the encryption scheme. So the semantic security is closely related to ciphertext distinguishability, as I told you. It is related to ciphertext indistinguishability. Distinguishability. That means given to ciphertext, if I am able to distinguish which one of them is for the message. This completes your security notion. I'll quickly recall what I think we had just covered. Types of attackers. So yeah, you have the following privilege, that is, he can read the message, he can try to get the key. If he is able to find the key, then it will be called total break. He can change the message. If he is able to change the message, it is called modification or attack on data integrity. You can pretend to be Alice, that is called man in the middle attack. So therefore the Eve can be either passive or active. A passive attacker can only read the message. Attacks that threaten the confidentiality are passive attacks. An active attacker can even modify the message or can harm the system. Attacks that threaten the integrity and availability are active attacks. So potential attacker goal is total break, partial break, or distinguishability of ciphertext. Total break means he is getting the secret key. Partial break, he is getting some information about the plain text. And distinguishability means he is able to distinguish between given two plain text, given two ciphertext, and he can distinguish they are of different plain text. Type of attack, the first one is ciphertext only attack. He will be given ciphertext, he have to find the key or plain text. Known plain text attack, that is KPA, he will be given encryption oracle for some of the messages, say mi, so it is some he'll be given mi and the encryption of mi, and then he will be asked to find the either key or decryption of some messages. Chosen plain text attack, CPA, and that means he will be asked to choose a plain text and will be giving the ciphertext of that, and then again the question will be to find the key. Then chosen ciphertext attack, yeah, he will be having the access of decryption oracle for the finite for the chosen ciphertext, actually whatever ciphertext, but again it will be finite. Adaptively chosen plain text, that means he can choose the plain text adaptively and get the ciphertext corresponding to that plain text. Same happens in the case of adaptively chosen ciphertext. He can adaptively choose the ciphertext and get the plain text. Security norms, the first one is computational security. That means if the base known algorithm used by current computer is unable to break the crypto system, then it is called computational secure. Probable secure, that means security of crypto system lies on some intractable or hard problem. Unconditional security, that means it cannot be broken even with infinite computational power. Symmetric security means given ciphertext, uh, whether the ciphertext leaks any information about the plain text or not. This is closely related to indistinguishability, ciphertext indistinguishability. Okay, thank you so much.